Okay, here we have the guided notes for solving systems of equations algebraically. Now, when we're solving systems of equations algebraically, there's some key characteristics that we can look out for. I want to make sure we're on the same page. Whenever you're solving systems of equations algebraically, it's important to make sure that your work is very organized. If it is not organized, it is very tough to go back and find out where did I make a mistake. It's really, really difficult as a teacher to pinpoint where some arithmetic mistake was made. Whenever you say 2 plus 3 is 6, well, that's going to ruin things for us. So, having your work organized is going to be really, really helpful. And I'm not above being the person that says 2 plus 3 is 6. So, just so you know, I make those mistakes all the time. And this is really where I learned how to be organized. So, as a student, this is one of the areas of mathematics that really lends itself to working on our mental organization and our problem solving organization. Some things to keep an eye out for. If you're solving a system of equations algebraically, and you end up with 0 equals 0, or like 7 equals 7, or a number equals a number, or a number equals itself, excuse me, then what does this mean? Well, does 0 equals 0? Yeah, 0 equals 0 every time. And so whenever I get this, I need to remember that there are infinitely many solutions. Infinitely many solutions. And then what does it mean when I end up with 0 equals a number? Well, when does 0 equal 7, for example? Well, that never happens. So for this one here, if I ever end up in this situation, there's no solution whatsoever. So, again, some key characteristics to look out for if and when we do come across that. We want to make sure we know what's happening here. And again, if it has a solution, then it is a consistent system. So, although this is consistent, it is dependent. So when 0 equals 0, it's a consistent and dependent system. Whereas 0 equals a number, no solution implies that it is a inconsistent system. All right. So let's try the first one out here. Now we have two main methods. The first one's substitution. And with this problem, here's our hint. We have to isolate the variable first. So of these four, now when I get a problem like this, my main focus goes right here. And I ask myself two things. One, are my x's above each other and my y's above each other? Yes. Two, are any of these four, are the coefficients a 1? And in this one, x plus 5y, that coefficient there for x is a 1. So I want to make sure that when I'm using substitution, whenever I'm using substitution, I want to make sure that I'm dealing with a variable that's all by itself. It's easier to solve for that guy because I don't have to divide and have any complicated fractions. And sometimes we have to have complicated fractions, and that's okay. I just want to make sure that if we can avoid it, let's avoid it. So I'm going to take this first equation here, and I'm going to solve it for x. So I get x plus 5y equals 3, and I'm going to subtract 5y from both sides. And I get x equals 3 minus 5y. And I'm going to take this x here, that's 3 minus 5y, and I'm going to plug it into the other equation for x. So now I get 2 times 3 minus 5y plus 3y equals negative 1. And now I can distribute and combine like terms. So the 2 distributed to this binomial gives us 6 minus 10y plus 3y equals negative 1. And I'm going to take 6 away from both sides in a combined like term, so subtract 6 from both sides. And negative 10 plus 3 is negative 7y equals negative 1 minus negative 7. Ooh, good. That's good. Because I could divide by negative 7. and I get y equals 1. Now, I have solved for a variable. I need to solve for the other one. So, x is already solved for with this one right here, isn't it? So I could take this y value and plug it into there, right here, and solve for x. And again, we really want to make sure everything's organized, and my pen is too big. Usually I'd write it just to the right here, but I'm going to go ahead and plug it in down below. So x equals 3 minus 5y. So x equals 3 minus 5, and y we know now is 1. So x equals 3 minus 5, which is negative 2. So I know my x value and my y value, and again we leave our answers, or solutions, in ordered pairs. So we have the ordered pair negative 2, 1. Not terrible. Not too bad. So let's just recap real quickly what we've done. We've picked one of the 4 variables here that was that had a coefficient of 1. In other words, it's the variable by itself. And I solved that equation for that variable. And then I took what it was equal to in terms of y, so x in terms of y, and I plugged it in for this x here. So I have 2 times 3 minus 5y. Basically, I wanted to get one equation with one variable. And that's good, because now I was able to solve for y, and then I could plug y back in to what I had solved for x for. I plugged my y back in here, and I could get my x value out. So I have x comma y, which is negative 2, 1. Okay, so now I want to run down elimination method real quick with you. Some key points here. Really the big idea is that we're going to get rid of one of the variables. We're going to add the 2 equations together and get rid of one of the variables. That's the rules to the game. Now, we need to make sure that the variables are lined up properly first, and we may need to multiply a line by a non-zero constant. And I'll explain that part in just a minute. But before we do anything with this system of equations, here, my variables aren't lined up right. So I need to manipulate this first equation. So if I add x to both sides of this top equation, so let's rewrite it here. I have 5y equals negative x plus 3. And if I add x to both sides, then I get x plus 5y equals 3. And here I have 2x plus 3y equals negative 1. Now, I have, excuse me, I just rewrote my second line just so I could look at my system here. Now, I know we've already done this problem. However, I want to see this problem done with elimination. So, I'm going to do this problem in 2 different ways. The first way, I'm going to eliminate x. Now, mind you, if I just add these 2 lines together, I'd end up with 3x plus 8y equals 2. And that does not help me because I did not eliminate a variable. Again, we're trying to eliminate a variable. So I need to multiply my top line by negative 2. And if I multiply my top line by negative 2, then I can add my 2 lines together, and I'll get rid of x. So that's my idea here. So I'm going to multiply my top line, and I just want to make a note to myself. So this top line here, this top line, I'm going to multiply by times negative 2. And when I do that, I get negative 2x minus 10y equals negative 6. And then I want to rewrite the same second line, and I get 2x plus 3y equals negative 1. Now I can add my lines together. When I add my lines together, negative 2x plus 2x goes away. Negative 10y plus 3y, negative 7y equals negative 6 plus negative 1 is negative 7. And dividing both sides by negative 7, again we get y equals 1. Now I need to plug y equals 1 back into one of my 2 original equations. Either one, it doesn't matter. Since x is already solved for, I'm going to plug it back into the original one, the top one, and I get x plus 5 times 1 equals 3. Subtract 5 from both sides, and x equals, whoa, Mr. Stevens, that's a little, x equals negative 2. Again, we get the solution set, negative 2 comma 1. Now, the reason why I did this in two ways, one in blue, and now I'm going to go back and do it again in red, or green. I want to see this, I want to take this system of equations, again, I've got it lined up, I got my variables all lined up. Here I eliminated x. With the blue work, I've eliminated x. What if I eliminate y? Well, here I have a 5y and a 3y. It's going to be terrible to do, but we can do it. So let's just say we wanted to eliminate y. So I'm going to take my first line and I need to multiply it by a number, and on my second line I need to multiply that by a number. Well, in order to get these lined up, it's like finding a common denominator almost. So I'm going to multiply the top line by, let's do 3, and the bottom line by negative 5. So here I'm going to multiply this line by 3. And here I'm going to multiply this line by negative 5. So distributing a 3 to every term up here, I get 3x plus 15y equals 9. Again, I have to multiply every single term by 3. And the bottom line I'm going to multiply by negative 5. So negative 5 times 2 is negative 10x minus 15y equals a positive 5. See what I did there? I got my y values to have the same opposite coefficients, Same value, opposite sign. Plus 15 minus 15. So when I add these together, I get negative 7x. Y goes away, equals, and 9 plus 5 is 14. Now I divided both sides by negative 7, and here I get x equals negative 2. And I can plug that back into either line. I'm going to plug it into the second one this time, and I'm going to say 2 times negative 2 plus 3y equals negative 1. 2 times negative 2 is negative 4 plus 3y equals negative 1. And add 4. And I end up with 3y equals 3. And divide by 3. So y equals 1. Hey! How about that? So now you've seen elimination in a way that we can eliminate either variable. As long as we do it right, we should end up with the correct answer.